Okay, good afternoon once again, everyone. So let's quickly review what we have discussed so far. Let me start with the base model. Okay. In order to create a base model where you're not going to use any of the regressors, diba? If you recall, sabi natin LM yan, ng dependent variable regressed on one. Data is equal to wage. Okay. And then let me just summary model 0. Okay. So this one, we're creating this object called model 0. Then ito yung model natin, linear model, hourly wage regress on 1. The 1 here indicates that you're just using hourly wage itself as the predictor. Okay, hindi natin ginagamit yung mga other variables ng coming from wage. Diba? So if I run this, okay, you'll see that the result is, yung coefficient natin, yung intercept lang, which is your, and this is, as we have shown, this to be the average of your hourly wage. Okay, so although it's statistically significant, no? Statistically significant, and then here, tinan nyo dito yung ANOVA natin, no? Residual standard error, 3.693, 526. Wala tayong p-value dito, wala tayong f-stat. Okay, kasi wala tayong analysis of variance dito. Okay, kasi wala tayong ginamit na predictor. Right, so that's the reason why there's no f-stat here. All right, then we used model 1, di ba? Very quickly, ano yung model 1 natin? Control Alt I. Model 1 is Alt minus is your LM, hourly wage, and then we use education, di ba? Data is equal to wage. And then summary, mod 1. Okay, I'm doing this quickly because I know we have done this in the past already, so this is just a very quick review. All right, so you can see here that model 1 natin, okay, ito yung intercept natin, not statistically significant, although still, if we're going to include, we're still going to include it in the model, even if you intercept in this statistically significant. Education is statistically significant, although sabi natin, this is not the actual value of your P. That's not the P value. And we said that we can look at it through the T value. If I'm not mistaken, I think the T critical is 3 point something. So we know that this is statistically significant, itong education, no? And we can look at the confidence interval, conf-int ni mod 1. Okay, it will give us the lower confidence value, confidence level ni education at saka ni intercept. Okay, so here you can see that the 95%, the true value of education lies between 0.44 and 0.65. Okay, so it does not touch 0. That's why this is statistically significant as compared to the intercept, diba? The intercept between negative 2.25 at 0.44. 0 is between this. So there's a possibility that your intercept is 0. Kaya nga hindi siya statistically significant. Okay? So I hope klaro sa atin to yung mga yung anatomy nitong regression output. Ito importante sa atin, this one. Okay? Here, we are comparing the okay, ito yung ANOVA natin. This is overall goodness of fit test. And our null hypothesis here is what? Ang null hypothesis natin dito, kino-compare natin yung base model natin, yung wala tayong regressor, at saka yung model 1 natin na may regressor tayo. Ang difference niya is B1, yung education. So ang null hypothesis natin dito is B1 is equal to 0. And the way to go about it is, sabi natin, 2 ways to do this. We can do an ANOVA comparing model 1 and model 0. Okay? So analysis of variance of model 1 and model 0. Si model 0 natin kanina ang ano natin ang estimate, ang prediction natin yung mean lang. Wala tayong ginamit na predictor. Si model 1 naman yung education kasama, no? And if we run this, okay. If we run that, okay. Comparison na to ng model 0 and model 1. Remember, ang null hypothesis natin dito, please don't forget that, ang null hypothesis natin dito is that your annotate natin. Null hypothesis natin can be written as our model 0. Model 0, which is our restricted, di ba? Restricted model natin si model 0 kasi si model 0, mas konti yung in fact, walang predictor to di ba? Is better. Okay? Or another way to put it is ang null hypothesis natin, B1 is equal to 0. Bakit B1? Kasi B1 yung dinagdag natin na predictor sa model 1 compared to model 0. So we're testing here, is the addition of B1 as a predictor of hourly wage statistically significant? Will it allow us to explain the variability of hourly wage more? Okay? And based on that, it turns out that ito yung analysis of variance, The p-value is less than 0.05. And we know that this is not the actual p-value, the minimum lang na floating point. Okay? So we're comparing two models. Si model 1 natin, may predictor tayo na education. This is model 2, model 0, ang predictor natin 1, which is just the average. No? And you can see here, okay, sino to? Residual, that degree of freedom ng residual, okay, this is si model 1. No? Kasi n minus k minus 1. Meron tayong k, di ba? Ang k natin, isang predictor, di ba? So that's 526 minus 1 minus 1, that's 524. Ito, n minus k minus 1, k is 0. No? Okay, so we're getting here, P-stat natin, we are rejecting the null hypothesis that model 0 is better. Mas maganda si model 1, yung unrestricted. Okay, so significant yung introduction ng B1 as a parameter. So B1 is statistically significant. Okay, so ibig sabihin since mas maganda si model 1 yung may predictor, okay, we don't just stop there, no? So what we do is, if you recall, anong ginagawa natin? Tinitingnan natin yung model natin. Okay. Isa lang pala, no? Sa model 1, isa lang dinagay natin. So ang gawin natin, okay, we're going to add all the other variables, no? So ito, nag-multiple linear regression na tayo dito. Very quick lang, mod 2, out minus, oops, sorry. Shift out. Okay, mod 2 is LM. Then you have hourly wage, shift tilde, regression education, regression everything na lang. That, okay, data is equal to wage. Okay, so di ba sabi natin na this one refers to all. Ibig sabihin lahat ng mga predictors. Okay, and then summary mod 2. Okay, then we have this output. Okay, and you can now see that there are variables that are not significant. Okay, mamaya babalikan natin to kasi we will not just remove all the predictors that are not significant. We will do what we call stepwise regression. So stepwise regression allows us to come with the better optimal model, no? Kasi you might be tempted to remove na lang natin lahat ng mga insignificant tapos yun yung final model natin. That cannot be done kasi sometimes in the course of removing some variables that are not significant, others become significant. Kaya nga hindi pwedeng tanggalin lahat, which you will see later in this case. No? So, okay, I hope you recall ano ibig sabihin itong race white, gender male. Quick review lang, sabi natin na mga factors yan and that R automatically assigns a dummy variable. Kung sino yung alphabetically appears first, female at saka male, female will be assigned the value of 1. So, the reference variable. So, si female yung 1, si male yung 0. So, when you interpret this, for example, ito 1.76, ibig sabihin nito, on the average, male employees receive $1.76 more than their female counterparts, ceteris paribus. So, it is interpreted in reference to your benchmark variable, which is the one that gets a value of 1. All right? Tapos, i-interpret natin to in the light of the reference variable. Okay, so, now, model 2 to, no? Now, which is better, model 2 or model 1? Kasi si model 1, education lang tayo. Si model 2, sinama natin lahat. So we'd like to know, does it make sense to include all the other variables? Okay, kasi remember, it doesn't mean na komot marami tayong predictors, ibig sabihin nun mas okay na kagad, no? There are certain parameters that we use in order to check whether mas okay yun. Number 1, may statistical test tayo. We can use the analysis of variance. Okay, so if we're going to compare model 0, okay. Si model 0, model 1 na tayo, no? Si model 1. Wala na si model 0 kasi mas maganda si model 1 eh. So, out na si model 0. Si model 0, model 1 pala, education ng pinasok natin. Si model 2, lahat to. No? Lahat ng mga predictors na yan. So, ang common sa kanila, education. Therefore, pag nag-analysis of variance tayo, ANOVA, comparing model 1 and model 2, we're actually comparing a model where you have education and you have education plus the rest. No? Kaya nga, when we do that, so let's, ang hirap kasi may problema itong itong mouse. I have to clear muna, tapos here, let's create an ANOVA. So, ANOVA, ni model 1, at saka model 2. Okay, we're comparing. We'd like to know sino mas maganda model. Kasi yun yung kino-compare natin ngayon, model 1, model 2. Pag rinan natin to, you can see here, model 1 is your restricted in this case, no? Kasi isa lang predictor. Model 2 is your unrestricted. So remember, the null hypothesis is always the restricted model is better. Or, another way to put it is, tingnan nyo yung mga dinagdag natin na variables. And then, it will be, di ba pareho education, di ba? So, B2 plus is equal to B3 is equal to B4 is equal to B5 is equal to B6 is equal to B7 is equal to 0. That's our null hypothesis sa ANOVA na to, no? Bakit? Kasi gusto natin matest kung yung dinagdag ba natin ng predictor, si B2 hanggang B7 hanggang number of dependents, are they statistically significant? And the answer is, class, ito, yung p-value na to. So this is very, very small compared to 0.05. It's significant at 0.001. Therefore, ang conclusion natin, we reject the null hypothesis that the restricted model is better. Or B2 is equal to B3, that is equal to B7 is equal to 0. Okay, there is, meron tayong, we're confident that statistically, at least one of this is not equal to 0. In fact, confidence interval natin, conf int, ni model 2, if we take a look at this, di ba yung mga pinasok natin, si experience hindi, no? Hindi siya statistically significant. Pero si tenure, okay, si gender, okay, so at least dalawa, oh. Si yung dinagdag natin, no? So si B2, hindi siya significant eh. So possible na maging zero yan. But si B3, no? It does not have zero in between. It's a lower and upper limits, no? Tapos si gender, ganun din. Si civil status at saka si number of dependents, hindi siya significant kasi may zero siya, no? In between. So at least si B3, okay, B4 and B6. Tama ba? B1, B2, B3 and B5. They're not equal to zero. Okay, so kaya may rin-eject natin na yung null hypothesis na the restricted model is better. So once we have that, anong gagawin natin susunod? Stepwise ulit, no? We choose the least absolute value ni T. Okay, so ang least absolute value ni T dito is number of dependents. So yun ang tatanggalin natin, no? That will be our leaving variable. Okay? So model 2 yan, di ba? I-copy natin to, Control C. Okay, Control 1. Dot and then minus, ano yung tatanggalin natin? Number of dependents, siya yung pinaka So everything minus number of dependents. Or you can write all the variables except number of dependents. And we'll call this model number 3. Model number 3. Okay? I hope, class, you're able to follow. Okay, shortcut lang to, no? Of course, pwede din ditong tilde, education, experience, lahat, except for the number of dependents, which is just the same as everything except the number of dependents. All right, run natin to. Okay, if you take a look now at this one, okay, we can compare, for example, the R squared, adjusted R squared, and you can see that there may be improvements as far as the succeeding model is concerned. Pero dito meron pa rin tayong mga hindi significant, no? Kaya mag-stepwise pa rin tayo dito. Pero i-compare natin, class. As usual, i-compare natin si model number 2 at saka model number 3. Okay, ANOVA, Analysis of Variance, model 3 and model 2. It doesn't matter, class, kung ano yung unahin nyo. No? Kung model 2, model 3, model 3, model 2, it doesn't matter. Kasi alam naman natin kung ano yung restricted dito. Ang restricted dito, class, si model 3. Kasi tinanggal na natin siya ng number of dependents. Alright. So you can now see here that, okay, ito yung natin. Okay, this is our plus number of dependents minus number of dependents. Okay, this one is our unrestricted kasi kasama si number of dependents. This one is our restricted. Ito yung model number, model number 2. Model number 3, no? Kasi minus number of dependents. All right, and then what's our conclusion? Okay, di ba sabi natin, ano ba yung null hypothesis natin? Ang null hypothesis natin is that the restricted model is better. Sino ba si restricted model, class? Yung walang number of dependents, ito. In this case, yung number 1 niya dito. Kasi minus si number of dependents yun. Okay? Ito kompleto hanggang number of dependents. And what's our conclusion? Our conclusion is p-value is 0.17. Okay, greater than 0.05. We reject the null hypothesis that, we fail to reject the null hypothesis that your restricted model is better. Okay. Ano yung null hypothesis dito? Diba sabi natin, okay, para clear lang, no? Laging HO is model number 3. Ito yung restricted, no? Is better. Model number 3 compared to model number 2 yan. Si model number 3, walang number of dependents. Model number 2, may number of dependents. Or class? Since ang naiiba sa kanila, number of dependents. Dito may number of dependents, dito wala. Minus 2 no? So therefore, since number of dependents is B7, here we're testing the null that B7 is equal to 0. Isa lang, no? Kasi isa lang naman yung magkaiba sa kanila, yung B7 lang. Okay, and since p-value is 0.18, what's our conclusion? We fail to reject the null hypothesis that B7 is equal to 0. Okay, there's strong statistical reason to believe that B7 is indeed equal to 0. And if B7 is equal to 0, then the number of dependents is not a, okay, ano siya? Hindi siya significant predictor ni hourly wage. Okay? So therefore, model 3 stays. No? Model 3 is better than model number 2. Okay, so ibig sabihin, mas maganda yung restricted model, mas maganda yung wala si number of dependents. Okay, so anong susunod natin dito? Next step is, ganun din, no? Stepwise. So si model number 4, titignan natin. So what's model number 4? Model number 4 will now be, ang leaving variable natin, ang aalisin natin dito, yung smallest t-value is, ano, class. Answer please, pakichat. What will be our leaving, L-E-A-V-I-N-G, yung aalis? Class, please. Raise ba? Bakit raise? Okay. Tama, no? Si raise nga. Kasi, siya yung pinakamaliit na t-value, absolute value. Ha? Okay, you don't consider the negative. So, si raise white ang tatanggalin natin. No? Okay, so, punta na tayo dito. Control Alt minus. Alright, model number 4 na tayo. Model number 4. Okay, which is LM, hourly wage. May shortcut to no? Anyway, may shortcut sana to yung model number 3 dapat. Then, ima-minus natin si, si raise. Pero sige, ano na lang. Just for clarity's sake. Okay, so, education. Ito yung long cut, no? Experience. Ano pa, class? Tenure. What else, class? Gender, no? Ano tinanggal natin? Race, di ba? Tinanggal. Plus civil status, no? Data is equal to wage. Summary. Mod 4. Okay, tama ba? Mod 4, LM. Hourly wage regressed on education plus experience plus gender. Ano mali ko dito, class? Gender yung pangalan ng ano, class, ha? Gender yung variable natin, hindi gender male. Yung gender male, inattach lang yung ano doon, yung dummy variable. Pero the name of the variable, tingnan nyo mabuti kung ano yung pangalan ng variable. Hindi naman nabago yun. Gender naman yun. Nung nag-dummy variable lang, inattach niya. No? Okay, I hope that's clear. Ano tinanggal natin? Gender ba? Race, di ba yung tinanggal? Class. Come on, please. So ito lang natin ang 5, di ba? Education, experience, tenure, gender, civil status. Correct? Okay, so wala na yung race. Tinanggal na natin. Okay, model number 4 na tayo, ha? All right. And then this is the result. Then of course, compare natin yung multiple R squared, in particular adjusted R squared. And then take a look at this, no? So dito, dadalawa na lang yung hindi significant experience and civil status. But before we even look at this, compare muna natin si model number 4, ANOVA. Does it make sense to generate model number 4? Compare natin kung mas maganda si model number 4 kay model number 3. Kasi kung mas maganda si model number 3, yung may race, di babalik tayo doon, no? Okay. And here you have p-value of 0.8775, which indeed tells us that mas maganda yung restricted. Mas maganda yung tinanggal natin si race. Ito. Unrestricted compared with unrestricted. May race to, ito wala. Null hypothesis, restricted is better, yung walang race. Inference, fail to reject the null hypothesis. Mas maganda nga yung walang race. Another hypothesis, another way to write it is beta is equal to, beta nung race is equal to 0. Conclusion, we failed to reject the null hypothesis that race is equal to 0. Ayan. So dito, makikita natin na model number 4 is better than model number 5 using ANOVA. Going back to model number 4, hindi pa tayo tapos, no? Stepwise regression, tatanggalin natin yung absolute na t-value, which is ito. In this case, it's the experience, no? So remove experience. Experience will be the leading variable. All right, Control Alt I. Let's now call it model number. Papayin ko na lang to, no? Ay, ito. Control C. Okay, mod number 5. Alt minus, Control V. So LM, hourly wage, regression, education, experience. Tatanggalin na sa experience, di ba? Tenure, okay. Data is equal to wage. Data is equal to wage. Close. Summary. Mod 5. Okay. Now take note that in model number 4, dalawang hindi significant. Okay. Dalawang hindi significant. That's why you should not remove all at once kasi, tingnan nyo to. Let's take a look at this. Okay, when we remove experience, what happened? Civil status became significant. Kanina hindi significant yan. And this is what I wanted to tell you, no? Na kaya nga, kunyari marami tayong variables, tapos yung first model natin, sinama natin lahat, tapos let's say marami doon ang insignificant. Hindi tayo nagtatanggal lahat-lahat kagad. Nagsi-stepwise regression tayo. Kasi when you remove other variables might become significant. Okay? So you can see here that lahat significant na, no? Okay? So, compare natin si mag-ANOVA tayo para lang just to check, no? ANOVA of model number 5 versus vis-a-vis model number 4. In this case, model number 5 is your restricted kasi wala siyang experience, no? Si model number 4, may experience siya na variable. When we run this, as you can see here, this is model number 4, yung unrestricted natin may experience. Dito wala. And if model 4, model 5 is to be better, yung walang experience, which is this one, this has to be, the p-value should be greater than 0.05. And true enough, no? So conclusion natin, just like the others, we fail to reject the null hypothesis that the restricted model, which is model 5, is better. So mas maganda nga natanggalin si experience. Okay? And with that, class, yan na yung complete natin na model. Then we can now write our model, hourly wage is equal to yung mga estimates na yan, no? Yung mga equation na yan. And then we'll have more examples of yung mga factors, no? Kasi hindi pa natin talaga na-discuss sila in greater detail. All right. Okay. Okay, kindly now open the stepwise regression. Yung shinare ko sa inyo. Okay, in case na hindi natin matapos to ngayon, may although yung recording ng isang section hindi rin namin natapos, pero we'll try to see where we can reach at this point. Okay. So balikan natin to, no? Let's go now here. stepwise regression. So there are some notes here. Saan ginagamit yung stepwise regression? It's an iterative construction of your model. So sabi natin, as I said a while ago, when you create your model, and then there are some insignificant variables, you do not remove all of them at once. You have to do stepwise regression. So there are three types of stepwise regression. Meron tayong forward selection. Meron tayong backward elimination or backward selection. And then meron tayong bidirectional. As the name suggests, yung forward, it starts with a zero-based model. And then isa-isang idadagdag yung mga predictors. Pipili siya. Kung idagdag ko to, ano mangyayari? Kung idagdag ko to, ano mangyayari? Kung idagdag ko to, ano mangyayari? Okay, so R will choose which variable is best to include in our model. And then pag na-add mo na yon, magdadagdag na naman ng isa step by step until such time na adding other variables does not make any sense. So ganoon din si backward. Si backward naman baliktad, no? Isasali lahat muna ng variables tapos tatanggalin isa-isa. This is what we did a while ago. Nag-stepwise regression tayo, backward tayong ginamit natin. And then lastly, you have bidirectional. Ang bidirectional, combination siya ng forward at saka backward. Okay, so medyo mas mahirap to, no? Kasi when you introduce a variable, pwede pa siyang tanggalin later on, no? Sa naman, sa backward, pag sa bidirectional, pag nagtanggal ka ng variable, later on pwede pa siyang ibalik. Which is not the case in forward at saka backward. Sa forward kasi, pag pinasok mo yung variable, hindi na siya pwedeng tanggalin. Sa backward naman, pag tinanggal mo siya, hindi na siya pwedeng ibalik ulit. Okay? So, of course, hindi foolproof yung stepwise regression, no? May mga instances na mali yung final output na generate. Okay, that's why others are calling for, may mga statisticians nga na nagsasabi na dapat hindi na ginagamit yan. Okay, but others still see the importance. Okay, for now, let's just assume that may relative importance on stepwise. So the package to use here is OLSRR. Ito, very convenient yung OLSRR. So kindly please load that. I-library nyo kung hindi nyo pa na-load. Bakit ba may dito? Sandali ha. Natatago yung ko eh. Okay. Yun. Natatago yung clock kaya hindi ko alam kung anong oras na. Okay, kindly run this. If you haven't installed that package, kindly, you know what to do. Install that packages. Then, i-library natin. Okay. All right, then let's recreate our model. Let's just name it model. So we're doing LM, linear model, hourly wage regress on all the 7 predictors. Data is equal to wage. Run natin to. Okay. So we have this. Andyan yung model natin, There. Okay, so based on that object that we created, yung model natin, which is actually mod 1 kanina. Okay, let's now do what we call stepwise regression. So yung unang gagamitin natin, yung forward. Okay, here. Forward selection. Ibig sabihin nito, class, magsisimula ng scratch si R. Okay, wala mo ng predictors, tapos isa-isa niyang ilalagay. Okay, so take a look at the code. I'm putting it in parentheses so that if we print automatically, I'm calling it forward fit.p. The function is this one, OLS underscore step underscore forward underscore p. So this means that there are two main methods, no, in forward. Meron tayong p value at saka meron AIC. Okay, sabi ko kanina ano yung AIC? Akaiki Information Criterion. So the entering variable, kasi forward to di ba? Kanina di ba ang model natin yung stepwise regression, yung backward. So leaving variable yung aalisin. Ito naman entering, ipapasok. So OLS step forward P, and then the model is yung regression model natin, and then entering variable is 0.05. Ibig sabihin nun, this is the level of significance. Ibig sabihin, a variable can only enter the model if its p-value is less than 0.05. Yan ang ibig sabihin nun. Okay, i-run natin to. Okay, and we will now see the output, ipiprint niya. Okay. What do you have here? Forward selection. Step by step, ang first na pinasok niya is education. Okay, so among the 7 variables, nakita niya na kung isa lang ipapasok ko, si education ang best, no? Okay, so andyan yung value ng R squared, andyan yung adjusted R squared. If you recall, di ba yung unang model natin, model 1, which is just education, ang adjusted R squared niya, 16.32%. And then you have here Mallows CP. Okay, kindly please just read on that. No? The Mallows CP is a metric that's used in order to compare models. So the lower the Mallows, the better the model. Ganun din itong si AIC. AIC stands for Akaiki. I think I wrote that in the other section. Ito, no? Akaiki Information Criterion. Meron pang iba niyan, no? SBC, Schwartz Bayesian Criterion, etc. But these are metrics of information losses. So pareho din siya ng Mallows CP. Okay, sulat ko yung Mallows, baka spelling din yung nakuha, no? Okay? Mallows CP ito, no? AIC, Akaiki Information Criterion, which is a measure of information loss. So the lower the AIC, the better. If you take a look at this one, plus, yung mga pinasok na variables, education muna, tapos tenure, gender, tapos civil status. Okay? So, nag-stop na siya dito, which is similar to the model that we had a while ago. But yung model 5 natin, 4 yung predictors siya, education, tenure, gender, and civil status. The rest were eliminated. So, in this case, yung forward selection natin, pareho dun sa sa na-generate na backward. No? Sometimes magkaiba. Okay? All right. So ito yung summary, no? Selection summary. So this is the forward selection method. Okay. Now, so ito, ang kaibahan nito, dito may details is equal to true. If you want to see the step-by-step process na ginawa ni R, you can run this, no? So dito linagay lang details is equal to true. And if we run that, you will see that all the steps that were undertaken in order to add. Kasi di ba forward selection to, di ba? Medyo mahaba nga lang. Okay, kasi isa niya 7 variables yan eh. So let's wait for the final output. Ang tagal. Kasi iniisa-isa niya. Okay. Okay, yan. Finally. All right, so forward selection, di ba? Sino yung mga candidates? 7 yan, di ba? 7 predictors. Okay, so anong unahin niya? Step 1. Ang pinaka nakita niya maganda is add education. Yan. So, remember, forward, no? So, nagsimula, walang predictor, tapos i-add education. Okay? So, may mga metrics dito, okay? May mga metrics dyan. And then, may ANOVA, okay? May parameter estimates. Ito yung una natin kanina, no? Okay, and then, forward selection, step number 2. Add tenure. Ayan. So, pinasok si tenure. Tapos ito nangyari, kung kapasok si tenure, okay, ang question, will the addition of tenure, will it be statistically significant? Yan. Kasi forward to, di ba? Tapos ang ginagamit natin si P. O ito. So, statistically significant si tenure. Okay? So, among the different variables, ang sinunod niyang, ang pinaka nakita niya maganda, education muna tapos si tenure. Tapos step 3, ipasok si gender. Tapos step 4, ipasok si civil status. Tapos, wala na. No more variables to be added. Sinamarize niya, add education, tenure, gender, civil status, etc. And then this is the final model, final output. Okay, pause muna ako. Any questions, class? Clear ba yung stepwise forward selection? Paki-chat naman please kung clear. Okay, thank you. Okay, thank you for the feedback. Now, ang kaninang ginamit natin, stepwise na P method, no? There's another method called forward selection na AIC naman yung gagamitin. So itong model na to, ipapasok niya yung variable for as long as bumababa yung AIC. Now, sometimes nagko-conflict tong p-value at saka kanina kasi forward selection using p-value. Ito naman, forward selection using AIC. Okay? So tingnan natin to, class. Let's see if ang function dito, OLS step forward underscore AIC model. No? Let's see what happens. Okay. You can now see there's a different solution. Dito, education, tenure, gender, civil status, sinama niya si experience. Okay, bakit niya sinama si experience? Bakit niya sinama si experience? Even if experience is not statistically significant, but since AIC value went down from 2639 again 2638, pinasok pa rin niya. Okay? So you can see here the discrepancy or the difference between yung p-value at saka AIC. Si AIC, for as long as bumaba yung AIC, ipapasok niya, even if your p-value is not statistically significant. Okay? I will not run this anymore. I-run nyo na lang to on your own para makita nyo yung details. No? Yung details. And then if we plot this, plot natin yung object na to na forward fit. Okay, you can see here that una muna pinasok si education, tapos si tenure, tapos si gender, tapos si civil status, tapos si experience. Notice that AIC went down hanggang experience. Now, hindi na niya sinama yung susunod kasi pag sinama pa yung susunod, aakyat na yung AIC. So this is the basis of AIC, forward selection using AIC. Okay? May conflict ba siya sa P? Yes, may conflict. Ano gagamitin natin? In our case, we use the p-value. Kasi dito, si experience hindi siya statistically significant. No? Kasi ang ginamit natin, ang basis lang yung AIC. Alright, the third method is this one. It's almost time. I hope quickly mapakita lang natin to. Ito, alam natin to backward selection. Kanina, p-enter. Ito ngayon, p-remaining. So bakit P remaining? Kasi ipapasok mo na lahat ng mga predictors. Tapos as long as yung p-value niyan remains at less than 0.05, kasama siya. So if we run this, itong OLS step backward underscore P, take a look at this. So ito, since, di ba, elimination to no? So una, tinanggal niya si race. Tapos tinanggal niya si number of dependents. Tapos tinanggal niya si experience. Bakit niya tinanggal si experience? Kasi hindi to statistically significant. Okay? So, similar to sa kanina natin, di ba? 3 beses tayo nag-delete. 3 beses tayo nag-remove. Okay? So, once again, I will not run this anymore kasi mahaba to, no? Check nyo na lang with details is equal to true. Papakita nyo sa inyo step by step. Okay? So, that's now your backward selection using p-values. Meron ding actually backward selection using AIC ito, no? Ito din. So if we run this, tingnan natin to using AIC naman, yung kanina using p-value, will it give us the same answer as as yung p-value? Okay? Hindi, no? Iba. Bakit iba? So we start with the full model. Tapos tinanggal niya si race, tapos tinanggal niya si number of dependents. Hindi niya tinanggal si experience. Even if experience is not statistically significant. Kasi, if it remove the experience, tataas yung AIC. Okay? ang basis niya AIC lang lagi, di ba? So dapat bumababa si AIC. Alright? So ipa-plot ko lang to, pakita natin. Yung backward, okay? Yung backward, tinan nyo, no? Based on AIC, full model, remove race, remove number of dependents, okay? Hindi niya rin remove sa experience. Bakit? Kasi tataas yung AIC pag tinanggal niya sa experience. So we can see here the difference between sa backward, not necessarily pareho yung P method at saka yung AIC method. In this case, magkaiba sila. Okay? Ito naman yung 1.5, stepwise to. No? Okay, I'll leave you class to hindi pa pala time, ano? Akala ko. Okay, may time pa tayo. All right. So very quickly lang, no? Anong ginawa natin? Forward selection using p-value, forward selection using AIC. Okay, pareho ba yung yung result? Pareho lang dun sa forward. Dun sa naman, okay, tama ba? Pareho ba? Wait ha. Just to be sure. Ito, using AIC. Hindi, magkaiba, no? So magkaiba si forward using p-value, forward using AIC. Forward using p-value, ang pinasok lang niya education, tenure, gender, civil status. Hindi niya sinama sa experience kasi sa experience not statistically significant. P-value niya greater than 0.05. AIC naman, ang objective niya i-minimize talaga yung AIC. So kasama si experience. Okay, but usually ang ginagamit yung p-value, no? So just be aware na may difference pala, no? Kasi sometimes AIC can be a good metric to compare models. Kasi sabi nga natin si AIC, it measures information loss. So the lower the AIC, the better. Okay. And then you have yung backward, magkaiban din, di ba? Backward using p-value and backward. Ito yung forward to no? Yung backward using p-value and backward using AIC, magkaiba din. And then we have here, stepwise naman. Ito yung stepwise yung combination ng forward at saka ng backward. Kaya tingnan nyo, both using P, pinapasok natin yung entering at saka remaining. If we run this and print natin, tingnan natin kung ano yung maging result. Okay, ulitin ko ha. Okay, magra-round lang ako dito. Para round, round ng kahit 2 decimal places na lang. Nag-error, saan ang mali ko? Okay, anyway class, sorry ha. Ayoko na isipin ko. sorry. Medyo hanapin ko pa yung syntax kung saan ako nagkamali. Ano na lang, pareho na lang yan, no? Okay. So what happened here? Stepwise selection, no? So dito, notice na ang ginamit niya, kasi pwedeng, sa stepwise, magsisimula muna na parang forward yan. So blanco muna, mag-add siya, add, tapos kung pwedeng i-subtract, subtract. So in this case, parehong panay add, wala siyang sinubtract. So in this case, it is akin to the forward selection. Okay, so ganun din, stepwise using AIC. I'll leave you class to look at that. No? Okay, so dito, okay. 1.7. Okay. Now take a look at this. This is where the power of OLSRR comes into play. Kasi sasabihin niya dito, please print all the possible solutions. when you click this, it will give us lahat ng combinations. No? Kunyari, isa lang na regressor, paano kung dalawa? Okay, if you take a look at this, index 1, 2, 3, 4, 5, 6. No? Ito, kung isang predictor lang. Index numbers hanggang 7. Index number 8, dalawang predictors, education and tenure. So lahat yan, combination ng lahat hanggang 13. Ito, sa 127 all in all. Si 127 lahat ng predictors, education, experience, etc. Okay, so it gives us lahat ng possible combinations. Binigay yung R squared, adjusted R squared, okay, Mallows CP, di ba? Ayan. And then you can print this as a data frame. Yan. So, pwede nating i-print. No? Okay. So, meron dito akong binigay na I don't know if you have this, but yeah, I think you have that. Pakibasa na lang ng konti yung Mallows. No? All right. So, plot compare natin to, no? Mod compare natin. Ito yung kanina, yung lahat ng models. Okay, what will this give us? Okay, take a look at this. Okay. Simulan natin dito. All right. Tingnan nyo to, class. No? If you're basing it on R squared, if you have only one predictor, index number 1, which is education, yung kanina, no? Yun ang dapat yung piliin. Kung dalawang predictors, ito yung mga predictors to, no? You have to choose index number 8. Asa na si index number 8? Ito. Ayan. Kung dalawa, ang predictors natin na pipiliin, no? Education and tenure. Yan daw yung pinaka-best. No? Okay, so it gives us a combination. Kung 3, kung 4. Kung 4, let's see. Based on, wag R squared, no? Kasi R squared, pag mas marami, mas maganda eh. I-base natin sa SBIC, SBC, Schwartz. Dito na lang sa, okay, magkaiba din to eh. Adjusted R squared, okay? Kung 4 predictors, index 64 daw. Ano yung index 64? Tingnan natin. Okay, so this is index 64. Yan, 'di ba? Ito yung natin, solution, 'di ba? Education plus tenure plus gender plus civil status. Okay? So mukhang yun ang recommend niya kung 4 yung predictors. No? Model compare. Okay, that's what this does. So yung triangle dito, yan ang nagsasabi na kung anong model ang dapat gamitin based on the index. All right? So time na pala, class, ano? So ito na lang, last na. Ano na lang naman to, no? If you plot this, what will this give you? OLS step best subset model. All right, so ito na yan, class, no? Best subset. So kung isang predictor lang, education lang gamitin. Pag 7, syempre lahat, no? And then it will give us the summary here. Summary ng, okay, R squared, adjusted R squared, okay, Mallows CP, AIC, SBIC, etc. So may comparison dito, no? There, no? It has a comparison. Okay, so let me stop here.